Hey guys, BuildZoid here, and today I'm going to be responding to this comment from CLDPT, which they left under the video testing the Asus Direct Power Bridge on the GTX 760 Direct CU2. And the comment is, Zotac has something similar on their high-end 30 or 40 series cards. Would love for you to figure out what those are and do. So I'm assuming that CLDPT is referring to the Zotac Power Boost modules. So this thing right here, you can see it on a 3070 Ti amp extreme. Also on the 2080 amp extreme, there's a Power Boost module. 1080 Ti amp extreme, this one has two of them, so it's twice as good. 980 Ti amp extreme, we've got a Power Boost module over there. And then also the GTX 970 amp extreme, as well as 980 amp extreme. And then there's like a bunch of other 970 and 980 amp variants that also have these Power Boost modules. But yeah, so basically since the 900 series, Zotac has been putting these Power Boost modules into their power delivery for NVIDIA GPU, for their like top end and like top end model for NVIDIA GPUs. So what are they and what do they do? Well, if we answer the question of what they are, we'll already know what they do, because they're not really, they look a lot fancier than they really are. So anyway, I picked up a broken 1070 Ti on eBay. The reason it's broken is because all of the memory chips are, well, somebody tried to replace the memory chips, did an amazing job of it, so the card showed up with the memory power delivery completely shorted out. Also, the memory chips are, like, kind of discolored, and, yeah, I'm not sure if the card is repairable, and I'm not sure if I want to put the memory chips it came with back on it again, because they really didn't look in great condition, but anyway, that doesn't concern us today. What concerns us is the Power Boost module found on the back of this 1070 Ti, and what the metal cover conceals. And what the metal cover conceals is disappointment. Or, well, I mean, it could be worse. There could have been nothing. It could have been empty. That would be more disappointing if you ask me. But yeah, if you were expecting some kind of like amazing special power delivery thingy, it is not that. It is literally just 6 SMD aluminum polymers under a fancy metal cover on top of a riser PCB. And now, I'm a big fan of SMD aluminum polymers, right? They have extremely low equivalent series resistance, extremely low equivalent series inductance. Then there's like a special 3-terminal variant, which has even lower equivalent series inductance. That's ludicrously expensive and not really regularly seen on most GPUs, but it does exist. So I am a big fan of SMD aluminum polymers, but like this, it's just SMD aluminum polymers. Like this is a bit like they're trying to make them look fancier than they really are, right? And also, I would argue that having them on top of this little like riser PCB is actually making them ever so slightly less effective, because again, the main like benefits of an SMD aluminum polymer, other than the like fact that they're low profile, so for like laptops they're basically a necessity, but aside from like electrically speaking, right, their main advantages are the extremely low equivalent series resistance, the extremely low equivalent series inductance. And the thing is about the riser PCB, like this riser PCB is going to have some inductance, right, because everything, like every piece of wire has some amount of inductance. It's going to have some resistance. So you would literally be better off just soldering the capacitors directly to the board instead of soldering them to a riser PCB and then soldering that to the board. Now, is that going to make a big difference? No. You know, when I say this like riser PCB has some inductance, I mean, it's like not, technically it's not zero inductance, right? Like it's going to be very, very low. So that's not really that much of an issue. In fact, SMD aluminum polymers, in my experience, like the ESR and ESL of these is so low that even if you are attaching them by like using wires, right? Like if you have if you're modding a GPU, you can attach SMD aluminum polymers with like wires, and wires are going to have even more inductance than, well, actually, I'm not sure how they'll compare to some vias. Nah, there's a bunch of vias in parallel. That should still be better. But wires have like more inductance than like flat metal, like, you know, planes in the PCB. But even with legs hanging off of them, SMD aluminum polymers perform amazingly well for power filtering. So, you know, the riser PCB, like, it's not actually making a, like, I think you'd really struggle to even measure the effects of this riser PCB, but it is, in my opinion, worth pointing out that, like, look, if you can mount the capacitors directly to the board, you're better off mounting them directly to the board instead of, you know, manufacturing this, like, riser PCB, then soldering the capacitors to the riser PCB, assembling it into this like power boost module, and then soldering that to the board. Especially since Zotac is evidently perfectly capable of attaching SMD aluminum polymers directly to the board without the need for a power boost module, right? So, like, those 6 capacitors that live in that power boost module, like, they could have just as easily done this with them, right? And arguably, if they were attaching them directly to the PCB, this might not even be the most optimal, like, layout from, like, an inductance and resistance. Well, mostly inductance. The resistance isn't probably going to change too much, but from, like, an inductance perspective, this might not be the most optimal way to lay them out. Right? But I'm not sure how much that would actually matter when you're not directly behind the GPU core. Directly behind the GPU core, you'll actually find that, like, the multilayer ceramics will often have alternating polarities as a means of optimizing the inductance of the actual PCB itself that they're attaching to. But coming directly off of the vCore VRM, that's probably not a concern. But yeah, it's just kind of silly to me that, you know, like, yep, it's just SMD aluminum polymers, and they're also on a riser PCB, so they're very marginally, unmeasurably worse than if they just soldered them directly to the board. And the thing I find interesting is, like, I'm guessing it's simpler to assemble the module and then solder the module to the board than it is to, like, solder the 6 polymers directly to the board and then solder the cover on top of that, I guess. Yeah, I guess the cover would have to be some kind of, like, through-hole component, so they'd have to have, like, slots in the PCB for that to attach over the polymers. But yeah, ultimately this is just, like, I don't need to test it. It's just capacitors. We all know what those do. So, and this is not even, like, the best way of attaching them to the board. So, yeah, a bit disappointing. So why does Zotac bother with these, like, power boost modules, which are actually just a bunch of capacitors trying to look really fancy? Well, see, back in the day, you could actually get some very fancy capacitors, and Zotac was a big fan of them. For example, these black rectangles. These are prod-lysers. They're also a type of polymer capacitor as far as I know, so I'm pretty sure they're solid, like there's no liquid electrolyte inside them. But these basically take the, like, low ESR, low ESL properties of your usual SMD polymer, and they really try to maximize them. Because the idea with prod-lysers was, like, you see all the little multilayer ceramics and, like, 2 polymers behind the GPU core. Also, I should point out the yellow, well, okay, the yellow doesn't necessarily mean it's a tantalum polymer, but in this case, these are tantalum polymers. You can also get tantalum polymers in black. Anyway, yeah, so you see and I'm just pointing that out because aluminum polymers and tantalum polymers, technically, both are polymer capacitors, but they are quite kind of different. I'm not going to say very different, but kind of different. So anyway, so they're not, like, you shouldn't mix them up because they are not the same. Anyway. But yeah, so the idea with prod-lysers was that you could basically take one big black rectangle and replace all of the multilayer ceramics and polymers directly behind the GPU core. Now, that's a great idea, except nobody actually really... Well, Asus did that on, like, a few 500 series cards, like the GTX 570 Direct CU2. I should have totally included a picture of that, but anyway. Yeah, so the idea with prod-lasers was like super low, like even lower ESR, even lower ESL, literally ESL so low that you can like use a polymer capacitor to replace multi-layer ceramics, right? Like the whole reason you have this mishmash of like larger multi-layer ceramics and even smaller multi-layer ceramics, and GTX 770s aren't even that fancy. There are some cards that will mix like 3 different package sizes of multi-layer ceramics directly behind the core, in order to basically optimize the ESR and ESL of the filtering capacitors directly behind the core. And the idea with the prod-lasers was like, nah, you just make this like super low ESR, ESL capacitor, and you slap one of them on, and you don't have to bother with all the multi-layer ceramics. In practice, well, in a lot of applications, that's actually a terrible idea, because prod-lasers have miserable endurance ratings. As far as I know, they were never manufactured with endurance ratings higher than like 2,000 hours at 85 degrees Celsius. For comparison, your like generic through-hole polymer capacitors are 2,000 hours at 105 degrees Celsius. So the same like endurance time, but at 20 degrees higher operating temperatures. And if you start getting into the like higher endurance variants of aluminum polymer through-hole capacitors, you can get 5,000 hours, 10,000 hours, these days even 20,000 hours. So yeah, the prod-lasers were not exactly high endurance, and in practice, they were actually kind of unreliable in a lot of applications. Not specifically on like high-end overclocking GPUs, because on high-end overclocking GPUs, like these are just kind of hanging out in the middle of nowhere, if you think about it, right? Like, the GPU core gets hot, the power stages get hot, but all those prod-lasers, they're like right here. This part of the PCB is not going to be getting very hot. Also, it's a GTX 680. It doesn't pull that much power. It's got a giant heatsink. It's going to be getting plenty of airflow. So yeah, in this application, the prod-lasers having kind of miserable, you know, endurance capabilities doesn't really matter. And the same is true even for like the GTX 570, where Asus put the prod-laser directly behind the core, because custom, you know, desktop GPUs don't really run that hot. But another really popular application for prod-lasers was laptops. And in laptops, these things die constantly. So eventually, and I'm pretty sure most prod-lasers actually sold in, like, for laptop applications and other places where they actually kind of suck, rather than high-end desktop GPUs, right? Because there's not really that, like, yeah, I would imagine the high-end desktop GPUs aren't exactly, probably don't move the same volumes that like generic laptops do. So eventually the black rectangle prod-lasers, yeah, those stopped getting manufactured completely. But before the black rectangles, Zotac actually used metal rectangles. I don't think these are prod-lasers. I don't know what the like official product name for these is. But we'll just go with metal prod-laser because they are kind of similar idea. As the prod-lasers. These are older, I think, as far as I know. But yeah, so before, Zotac used these. And these have an uncanny resemblance with the power boost modules. Right? Metal casing, like metal rectangle, like slightly gold-tinted metal rectangle with red lettering versus slightly gold-tinted metal rectangle with red lettering. So yeah, that's the visual, like that's what the power boost modules are visually supposed to like reference. And the thing is, these went away basically for the same reason that the prod-lasers did, as far as I know. Also not super reliable. These are actually, I think, worse. At least some of the early ones were. Like, Asus used, also Zotac wasn't the only one using them. Again, Asus used them. Like here you can see one on a HD 5870 matrix, right, hanging out over here by the core. Also, Asus used them on motherboards. You can see on this Rampage 2 Extreme over here, and also for the memory. And the thing is, I'm not sure, like, these are actually known to fail short circuit. So that's, as far as I know, the prod-lasers just kind of fail open, I think. These, on the other hand, which is still not good, right? Like, if you have a prod-laser sitting behind your CPU or your GPU, and it's literally responsible for 100% of the, like, high-frequency decoupling, and it goes away, it's like all of the capacitors just got shaved off. which doesn't mean it won't work anymore, but it will be incredibly unstable. So yeah, I don't think the prod lasers were actually liable to short out. Now, the metal ones, on the other hand, these are liable to short out, which is worse, because depending on what kind of power delivery system is hooked up to them when they short out, it can lead to more issues further up the power delivery chain, right? So, yeah, these also eventually stopped getting manufactured, probably because they're also, like, actually, I'm not sure how unreliable these are. These are notorious for being, like, not very reliable. These, on the other hand, I'm not really heard to... Like, I know for a fact that with, like, Rampage Extremes, it's not super... Like, it's kind of common that you'll have shorted, like, Fujitsus. Back then, they were still branded Fujitsu, which, yeah, I couldn't find a better photo, unfortunately. But yeah, so these used to be branded like Fujitsu, and I think they might have gotten sold to Nichicon or something. Like the product line might have gotten sold to Nichicon or something. I don't know why they use the FP cap name, because that's also what like through-hole polymers from Nichicon are called, FP caps. But anyway, yeah. So like on Rampage Extremes, it's actually quite common to find these shorted out. But the thing is, the Rampage Extreme is extremely old, right? Like, that motherboard is, like, it's super duper old. It's over, I'm pretty sure it's over 20 years old now. No, not 20. Well, easily more than, like, 15 years. 15, yeah, probably more than 15 years old. I don't know my LGA 775, okay? Like, I don't, too old for me. If it's older than X58, I don't know what it is. So, anyway... so yeah, but these weren't exactly reliable either. And so I imagine they went away for the same reason that the prod lasers did. Or maybe these were just too expensive for what they do. I'm not sure. But yeah, for one reason or another, the actual manufacturers of like, well, the manufacturer of these and the manufacturer of these both decided that actually these are not worth producing anymore. The prod lasers, that's pretty self-explanatory. They were kind of awfully unreliable. These, on the other hand, I guess they weren't, like, maybe they just cost too much or something for what they are. Right? Because at the same time, like, multi-layer ceramic capacitors have been getting better and better in terms of how much capacitance you can get. Like, these days, you can get 0805s that are, like, 100 microfarads, which is insane. So, yeah, yeah. Whereas, like, back in the day, like, the 0805s on something like a GTX 680, I would guess top out at probably 22 microfarads, if even that. No, it should be 22. But yeah, but you can get 0805s now that are, like, 100 microfarads. So, like, these were a lot more competitive with their, you know, multi-layer ceramic counterparts when they were new. And I guess they might have gotten phased out just because they stopped being a good alternative or something. But anyway, Zotac, like, used these as, like, a big marketing point of their various GPUs, or, like, of their, like, Extreme Edition GPUs. And so when, I guess these were made by Nichicon, since there's FP on, like, their FP caps. So anyway, when these stopped getting made, and when NEC stopped making the prod lasers, Zotac was kind of in an awkward situation of like, well, we want the fancy metal capacitors, but nobody makes them anymore. So the Power Boost module was born, you know, by just slapping regular polymers under a metal cover. And personally, like, I'm conflicted about this because I think it's kind of, like, visually, I think it's kind of cool. Like, I think especially the metal prod lasers look freaking awesome. As unreliable as they are, they do look really cool. So I can kind of get why you would want, like, something, like, it look like, I still think the Power Boost modules look cool. Like, that's actually why I went and bought a broken 1070 Ti instead of just disassembling the Power Boost module on my working GTX 980, right? Because I didn't want to ruin the looks. Like, I know it's just polymers under there, but I think like, I agree with Zotac. These do look kind of cool. But yeah, they're actually just aluminum polymer, like, they're just SMD aluminum polymers in a fancy metal cover. It's a bit of a shame, I guess, that you can't get custom colors for aluminum polymers. Like for the through-hole capacitors, right? You like ASRock had golden through-hole capacitors. Asus has like had the like black nickel through-hole capacitors. Actually, they still have those, I think. Gigabyte has black ones. MSI has black ones. So yeah, if you're a big enough manufacturer, you can get through-hole capacitors in like, I would assume basically any color you want. Like, I'm pretty sure if you have a big enough order quantity, you could get them in pink. But I've never seen SMD aluminum polymers in anything other than black. Yeah, they're always black. So, which I guess is a bit of a shame, because these are actually just like from a ESR ESL perspective, these are just better than your through-hole polymers. Like, it doesn't matter if your through-hole polymers are gold or black nickel. One black rectangle is better, okay? And it's just a shame that we can't get them in like, well, gold, I guess, or like any other color really. Though, I guess, well, you can kind of see that Zotac even tried to get, like, fancier looking SMD polymers, because that's why they went with the yellow tantalums, which are, funnily enough, electrically not really any better than the black ones. They're just higher endurance ratings, which, kind of pointless in my opinion. Right, again, because, like they're mixing incredibly unreliable. Well, I guess the counter argument there is like, yeah, but we're mixing these like incredibly unreliable prod-lysers with these extremely, or well, actually the tantalums I wouldn't even consider them extremely reliable, but more reliable than the prod-lysers, so that counts for something, I guess. The thing, I'm not really a big fan of tantalums because as far as I know, these also have like a catastrophic failure mode where they'll just short out even if they're installed the correct way around, whereas aluminum polymers, as far as I know, even if you okay, well, if you massively overvolt them, they'll just short out because with enough voltage everything becomes a conductor. But if you have like an aluminum polymer just like die of aging or just die from high temperatures, they won't generally short out. As far as I know, they fail open. Unless you install them backwards, in which case they're immediately they immediately short circuit, in my experience. Definitely didn't burn myself on a capacitor that I installed backwards on a GPU. Totally didn't happen. Yeah, so Zotac was like, basically this is all about the looks of like, oh, look, we got these fancy capacitors. Instead, and yeah, so we have the power boost module. And I think it's honestly kind of a shame that, especially like if you want really fancy aluminum polymers today, you have the 3-terminal SP caps from Panasonic, which are like it's basically, well, it's a packaging optimization to further reduce the ESL. So instead of just having a like one negative and one positive end on the capacitor, you actually get 2 negatives, and so there's like an extra middle pad that's like an extra negative pad on the capacitor. Instead of just the 1 positive, 1 negative, you get 1 positive and 2 negatives, and that that has like a lower ESL. And yeah, those look basically identical to the 2-terminal versions, and the only way you can really spot them is because you'll have like a little nub right down like near the middle where the 3rd pad is, because the pad extends out towards the like outer edges of the capacitor, so you can just about see the outer edge of that inside middle pad. And those, like the Asus Z790 Apex uses those. I'm a big fan of that board, partially because of those capacitors. And a lot of like high-end AMD GPUs use those. Like, actually, not even high-end. A lot of AMD like reference workstation cards, old ones. Vega uses 2-terminal SMD polymers, but the Fury X uses the 3-terminal variant. Yeah, the Fury X uses the 3-terminal ones. I think the WX3100 uses the 3-terminal ones. A bunch of the Fire Pro cards. Like, if you just go through Fire Pro cards, a lot of those use the 3-terminal SMD aluminum polymers. I'm not really sure why, because they are being just used as like bulk filtering, so it shouldn't even matter that much that they have the like lower ESL. especially when you consider that the Fire Pro and like the various workstation cards are clocked lower than like the gaming cards. So in terms of like power delivery requirements, the gaming cards are actually more difficult on the power delivery than the workstation cards. But yeah, it's just like a thing that a lot of AMD reference cards will use the 3-terminal SMD aluminum polymers. At least like, well, I shouldn't say reference cards because it's not true. It's only true for like workstation cards, and then some of the like, well, the Fury X. Yeah, so that's a lot of unnecessary information about capacitors. Hopefully you found it somewhat interesting, even if it really isn't very useful, unless you're designing a board, I guess, maybe. Then it's like, yeah, you can, you know. The thing is, there's like a lot of different ways to achieve kind of similar results when it comes to capacitors, right? Because you can always, like, instead of using, say, the 3-terminal SMD aluminum polymers from Panasonic, which are really expensive for what they are, multi-layer ceramics exist, and multi-layer ceramics are cheap, as long as you don't need too much capacitance. So, you know, that's why, like, behind the GPU core... Actually, this is one thing I've wondered, is, like, why didn't NVIDIA... Like, NVIDIA is the only manufacturer to put SMD aluminum polymers directly behind the GPU core. Like, that's standard for a lot of NVIDIA cards, and yet they use the cheaper 2-terminal ones instead of the 3-terminal ones. When, especially behind the core, you would assume that having the somewhat lower ESL of the 3-terminal ones would be better. But, like, the padding just isn't there, so they can't, like, you can't actually do that, because the PCB isn't designed for it, but, like, why isn't it designed for that? Like, they wouldn't even necessarily have to actually use the pads. That's actually something you'll see on some NVIDIA cards where they'll have the pads behind the GPU core set up for, like, a few different types of capacitors, depending on how much they want to cost optimize the card. So you'll have, like, an option of, well, multi-layer ceramics or aluminum polymers, or tantalum polymers, whatever polymers you want, right? Yeah. So I'm surprised, like, there's never been an NVIDIA card where they have the option of the 3-terminal SMD polymers. I guess the issue with those is, as far as I know, they're only made by Panasonic, so maybe it's like, oh, these are too niche in their production that they don't want to use them, and so it's not even an option. Anyway, that'll actually be it for this video. Somehow it keeps getting way longer than... When I first saw the comment, I was like, oh, this will be an easy short video. And yet here we are. So anyway, hopefully you found this somewhat interesting, because I can't see it being particularly useful. And that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. So thank you for watching and goodbye.